So we're looking at the key right now for the parallel transversal triangle exploration that we did the other day. And of course, we found all of these angle measures using different things like linear pairs and vertical angles. Of course, linear pairs, right? Two angles that are adjacent and supplementary. Vertical angles are two angles that are across from each other when two lines intersect. Vertical angles are always congruent. Of course, we had our angle sum theorem where we could add up the angles of the triangle. I don't know if you caught this one or not, but this is the external angle theorem right here. This 125 is equal to the two non-adjacent interior angles of this big triangle right here. So a lot of different ways that you could have come up with these different angle measures. But what we want to go now to is to see how this relates to the properties of parallelograms. And that's what we're after right here, is the property of parallelograms. Now, there are 5 properties of parallelograms. You can see that I have listed out here, and you should have these already on your paper in some form or language or another. This will probably be the language that I use, but again, you may have found it in a different language, and that's okay. So property number 1 right here, the opposite sides of a parallelogram are parallel. We'll talk about what that means. Opposite sides are also congruent here on number 2. Opposite angles are congruent on number 3. Consecutive angles are supplementary. That means they add to 180, right? And then, of course, the diagonals bisect each other. So the purpose of this video is to kind of look at these 5 properties and see how they play out so that you have a good understanding of them and how to use them. Now, this last part where I asked you to use some color to highlight all the parallelograms in the picture above, let's take a look at what we've got there. So there's actually 3 parallelograms up here. There's this first one right here that contains angles 8, 11, 15, and 19. There's actually another parallelogram right here containing all of these angles. There's actually a third bigger parallelogram right here, and all of these properties that we just discussed below are going to come into play with all of those. But I want to just focus in on these 2 parallelograms, this one here and this one here, to kind of help highlight these properties that we're talking about. So I'm just going to kind of put some color on these first. So we'll put this one up here in blue just so we can reference the blue parallelogram. And then let's change the other color. How about to green? So we'll change the other color to green. And we'll talk about the green parallelogram down here at this point. Okay, so a couple things that I want you to see. Let's talk about these properties. So I'm going to go to property number 1. Opposite sides of a parallelogram are parallel. Well, okay, yeah, it's a parallelogram, right? So I mean, they need to have parallel sides. And we can see here that with the blue parallelogram, these are already marked for us. You know, this side is parallel with this side. But what makes them opposite sides, this is important you understand this, opposite sides do not touch each other. Of course, they're parallel. They wouldn't touch each other, right? So these 2 sides of the shape would be considered adjacent sides, where these 2 sides of the shape would be considered opposite sides. Important you understand that language. Okay, these are the opposite sides and they're parallel. And again, same thing you can see here. Opposite sides, this one running up and down and this one here, are parallel. Now, if they weren't marked, but we did know some of this information, we could use the converse of our angle relationships to figure out that lines are parallel and sides are parallel. And that might be something that you have to do in a proof. Like, for example, we see that angle 7 and angle 11 are corresponding angles for these 2 lines right here. So if we wanted to prove that this side of the parallelogram was actually parallel to the other side, we could say, well, based on the fact that we have corresponding angles that are congruent, that only happens when we have parallel lines. So the converse of the corresponding angles postulate would tell us that these 2 sides would have to be parallel. So if they weren't marked, we could use the converse of any of those line relationships. Again, same thing here. Let's say we wanted to show that these 2 lines were parallel and we weren't sure. We could actually use these 2 angles right here. These are same side interior angles, right? And any of the same side angles are supplementary. So if we've got same side interior angles that add up to 180 degrees, then the converse of same side interior is going to tell us that those 2 angles those 2 sides are parallel because of that as well. Okay, so opposite sides of a parallelogram are parallel. We're going to get back to this one, opposite sides are congruent, in a minute, because we're going to kind of prove our way through the green parallelogram. Let's talk about opposite angles are congruent. So again, in this blue parallelogram up here, you can see, look at the angles that are opposite. They are across from each other. That's what the opposite angles mean. They are congruent. Okay, and again, we can see that with all the different angle relationships we pulled out. The opposite angles are congruent. So that's what you need to understand about these angles here are considered the opposite angles from each other, and then these angles here, again, opposite angles. When we were talking about the isosceles triangles, we were talking about opposite being across the room, right? So, you know, these are across the room. 19 is across the room from 8. 11 is across the room from 15. So those are opposite angles, and you can see that they are congruent. All right, let's talk about this number 4 right here. Consecutive angles are supplementary. All right, this one's kind of interesting. Sometimes we get stuck on the consecutive language, but let me remind you of something that, you know, when we were looking at some of these proofs here, we were able to use this language right here. Check this out. Same side interior. And we could match that with consecutive interior. You remember that language worked the same way? We could call same side interior angles consecutive interior angles. So when we go back and we look at the blue parallelogram up here, you can see that this angle here and this angle here are same side interior angles for these parallel lines on this transversal, and they are in fact supplementary. We could have called those consecutive interior angles. And when we talk about it in a parallelogram, and this is the important part, the angles that are in a row next to each other, moving across like that, so not opposite, these angles right here would be considered consecutive angles, and you can see that those are supplementary. So let me show you, watch carefully, let me show you the consecutive angles in here. 15 and 8 are consecutive angles. 8 and 11 are consecutive angles. 11 and 19 are consecutive angles, and 19 and 15 are consecutive angles, and each pair of consecutive angles is always supplementary. So that covers property number 4 right here. So that leaves us with then to talk about the opposite sides are congruent and the diagonals bisecting each other, and we're going to do that in the green parallelogram down here because we want to look at it in terms of how can we prove this. I mean, if you take, for example, this green parallelogram, yes, we know the sides are parallel. Yes, we know a lot of information about the angles, but we don't know anything about the lengths of these sides. So we can't really say anything about these sides being congruent because we don't know anything about the lengths of the sides. But actually we do, and we're going to take a look at that in just a second. The other thing that I want to be on the lookout for in here is what we call diagonals. This is the first time we've talked about a diagonal in this class. So a diagonal is a line segment or a line that connects opposite angles. Okay, so where are the opposite angles? Well, this one right here, these two angles combine together, that's an opposite angle. With this is an opposite angle, and the line that connects those is called a diagonal. So, I mean, I think you know what a diagonal line is, but you need to know the official definition is that a diagonal connects opposite angles. That's what a diagonal does. It connects opposite angles. Again, you can see it over here. We've got this angle. This is the diagonal that connects those two sets of opposite angles. Diagonals connect opposite angles. And what we're saying in our properties down here is that the diagonals of a parallelogram bisect each other. Remember, this is a really important geometry word. It doesn't just mean cut, into two parts. It means to cut into two congruent parts. And so if this diagonal bisects this diagonal and vice versa, if they bisect each other, then that means that this diagonal is getting cut exactly in half. This piece has to be equal to this piece, and this piece has to be equal to this piece. They're cutting each other in half. That's what diagonals bisect each other in half means. They're cutting each other in half. Now we got to really be able to prove that, and we're going to do that using our triangle congruence proofs. So let's talk about how this works, okay? If we don't know anything about these side lengths on this parallelogram, it's going to make it hard for us to decide, do we know congruency? But let's see what we do know. Actually, this triangle right here that I'm highlighting on the screen is a special kind of triangle. I want you to notice something. This angle down here is 55 degrees. This angle over here is 55 degrees. And this angle up here is 70 degrees. Now, we talked about a special kind of triangle the other day where you have two base angles that are congruent. Okay, what kind of triangle is that? It's an isosceles triangle. the isosceles triangle has at least two congruent base angles. And what we learned about the congruent base angles was we could say this for sure. The sides that were opposite or across the room from the base angles would be congruent themselves. Okay, so now let's mark those because we need to be clear what that is. So if this is our isosceles triangle, then what we're saying is if this is a base angle at 55 degrees and this is a base angle at 55 degrees, that makes this side of the triangle congruent to this side of the triangle right here. So I'm going to mark those with a blue congruency mark. So I'm going to take this and I'm going to put a big blue congruency mark here and a big blue congruency mark over here. And I want you to understand that that blue congruency mark represents this whole side of the triangle and this whole side of the triangle, right? So we've got the isosceles 55 degrees, 55 degrees. So then the opposite sides of the triangle are congruent. But I want you to notice something else. Take a look at this triangle right here. So in this triangle right here, we've got a 55 degree angle, a 55 degree angle, and a 70 degree angle, which means what? It means that this also is an isosceles triangle. And since this one side is opposite a 55 degree angle, okay, and this is the other side that's opposite the 55 degree angle, we now know that in this isosceles triangle, this side must be congruent to this side. Well, check this out. We already have a single blue congruency mark on this side. In fact, this is a reflexive side for both triangles. This side is present in both the first triangle and in the second triangle. So since this has a length of one congruency mark, that means this needs a length of one congruency mark also. And so we're going to put a one congruency mark over here. Now, I want you to be able to see this, all right? So we have a one congruency mark, and we have a 70 degree angle and a one congruency mark. We have a one congruency mark, a 70 degree angle, and a one congruency mark. We can now say that these two triangles, this triangle right here and this triangle right here, are congruent triangles by what triangle congruence theorem? Try to figure it out. Which one is it? Pause if you need to. We have a side, angle, side congruency. Side, angle, side congruency. Okay, now we know some other things then. If we have two congruent triangles, then if the triangles themselves are congruent, then that means that all of the corresponding parts are congruent, right? And that is, of course, our CPCTC. Corresponding parts of congruent triangles are congruent, right? So here's what we know now. Watch this. We knew that this side and this side were congruent, and we know that this side and this side were congruent because they were isosceles triangles, but now we know something else. And I'm going to mark these in, what color should I mark these in? Okay, I'm going to mark these in a light blue, and I'm going to put two congruency marks here because they're different than the other one. And how do I know they're different? How do I know that this is not the same length as these? Well, if this was the same length as these, we'd have an equilateral triangle, which means that all three angles would need to be 60 degrees, right? And that's not the case. So we now know that that's different. So I can mark both of those with two congruency marks. All right, so now we've marked those with two congruency marks. Let's take a look at what we now know. Let's consider for a second this triangle right here and this triangle right here. All right, well now what do we know that we have? Well, let's take a look. Let's see, we have a 30 degree angle and a double blue congruency and a 55 degree angle. We have a 30 degree angle, a double blue congruency, and a 55 degree angle. Hey, that lets us say something, doesn't it? That lets us say that this triangle right here is congruent to this triangle right here based on what triangle congruence theorem? Angle, side, angle. Angle, side, angle. All right, now that tells us something, right? Because if this triangle right here is congruent to this triangle right here, now we know that the other corresponding parts of those triangles are themselves congruent. Okay, so we need to mark some new congruency markings. So now we're going to say that this portion right here is congruent to this portion right here. And again, we know that because that's the side that stretches between the 30 and the 95. That's the side that stretches between the 30 and 95. That makes from here to here congruent, and here to here congruent as well. Now that should start to show you something right there, because that was our diagonal, right? And what happens at this intersection point is that diagonal is now cut into two congruent parts, isn't it? Okay, but we also know something else, don't we? From the same triangles, we know that this side that stretches between the 55 and the 95 and this side that stretches between the 55 and the 95, those must also be congruent. I'm going to put 4 markings there, and that's just on the little piece. 1, 2, 3, 4. And those 4 markings mean that it's just this piece right here and just this piece right here. It's just this side of this triangle and just this side of this triangle. Okay, so now what we've established is from those congruent triangles, we've now said, look, this diagonal is also cut in half. So the whole point of going through all of these is for you to see a couple things, all right? We used the isosceles triangles here to prove congruence triangles, which got us, first off, that this side is congruent to this side. They are opposite sides of each other. Now, our first property was opposite sides are parallel, but now because of this, we were also able to show that opposite sides are in fact congruent, okay? And then because of CPCTC, we were able to show that these two opposite sides were also congruent because they were part of the big isosceles triangles. Then we used those to prove these little triangles were congruent in here, and that gave us the pieces of the diagonals. You can see that the diagonals have been cut into 2 equal parts on each one, so the diagonals have bisected each other right in the middle, so that this diagonal is cut into 2 congruent parts and this diagonal is cut into 2 congruent parts. Okay, and so that sums up for us all 5 of these properties down here. The opposite sides of a parallelogram are parallel, opposite sides are congruent, opposite angles are congruent, consecutive or same side angles are supplementary, and finally the diagonals bisect each other. All parallelograms share these 5 qualities.